This is about one of one of the most interesting challenges with when you are developing. You go to a project and you submit a PR and it's just failing, and what you usually do, you retry. You retry forever, you retry for days, you retry for weeks, and sometimes it goes through. But what you don't understand is that maybe somebody was fixing the test in, in the background. And this is what happens, and this is what focuses less. When you send a PR, when you have something that is failing, sometimes doesn't fail, sometimes fail, you need to check why. And to check why, first you need to understand the different layers of testing that we have. If we see this as a pyramid, we can see that this is how Kubernetes tests. Okay, we have a lot of linters in the low level that verifies. Okay, this is a static check analysis. You have your this function is missing one parameter, or typical things that usually all the IDs check now. Then you have unit tests. When you do unit tests, you create, I don't know, a function, a method or something, and you want to use some inputs and outputs and assert the result. Usually this doesn't go beyond one file, and as I said, are very target for one function or method or something specifically that doesn't involve many components. But then things get uglier, and you have a database, or you have some external component that you depend on, and this is when you start mocking things, but you still need this something else. In Kubernetes, typically integration means you have an API server, right? And an etcd database. So basically, the integration framework in Kubernetes that creates that part for you. It creates an API server with an etcd, and then you can do your thing with typically a controller or something like that. And then this becomes more problematic because you want to test how the user is going to use this feature. That's what we call E2E or end-to-end. Then these tests involve much more components. You may have a full cluster or a full cluster with a cloud provider that creates load balancer, and your logic has to test all these components, all these interactions of the supposed user with the system. And the next level, that's something that is much more complex, is when you test all these things, but at the scale, okay? That work with 3, 4 nodes, but now what happens with 100 nodes? What happens with 1,000 nodes? The problems, are much, much difficult to see at the scale. You even don't know which part of your system is going to break, and usually because of this complexity, these are the last tests that you add and the fewer tests that runs only every, I don't know, several days or periodically. How this is structured in Kubernetes, we are, as an open source project, we are bad with documentation, but we do have documentation. Maybe these things are stale, but at least they are useful. If you want to deep dive into more of the topics, they are good starting points. And maybe, as I say, maybe they are not up to date, but the foundations or everything that you need to know to start with are there. So I throw the links if you want to use it for later. And one of the things that we have and we don't promote enough is all the tooling that we have. So Kubernetes has a lot of tooling for tests. And my experience with most of the people that is new to the project, that they don't even know about these tools. You can see that some of the URLs are storage.googleapis.com. So it speaks for itself, right? You need to know that URL exists. It's just not that you can reach there. And the other are tools like Pro that is just not only a CI system that runs all the tests. It also has some nice reporting tools. And one of the most important tools that I see a lot of value in it is TestGrid. I think that right now half of it is open source, and they are trying to move everything to open source. But TestGrid is a great reporting tool, especially to look for flakes and history of a job or a test. It is one in the. So first of all, who is not familiar with these tools? More or less, you are not familiar with the tools. Okay. So when we are going to do an exercise later, and we can go through all the process that I follow, that is not the one. Everybody should create its workflows. This is very specific for the person, but what I will do is I will run some example, we'll use the tools, and you will see how they can be used for solving flex problems and these kind of things. Okay, so we talked about the tests, how we test, and the tools that we have. And now we have a flake. We have a test that sometimes passes and other times doesn't pass. So the most important thing is finding the root cause. Because this is a common problem. You find a test that is failing and you say, I can add and sleep here and the test pass. The goal is not to pass the test. The goal is to understand what is failing. Because most of the times it hides something that is wrong in the code base. And this is one mindset that we need to change. Is that the goal of the test is not to pass. The goal of the test is to verify and to assert that something works the way that the test the test is supposed to assert. And this is when the things got more problematic, because if something passes and sometimes doesn't pass, it can be because a lot of different things. So the first thing that you need to do is to try to correlate. But important thing with correlation, it doesn't imply causality. So if you know that this test started failing yesterday, and yesterday somebody merged something related to that, it's a good, it's a good starting point. But it doesn't mean that since that emerged yesterday, that's the reason. Okay, and this happens a lot, or I don't know, typical symptoms. With network, we have a lot of this. Because this test failed with I cannot reach endpoints, then all the tests that fails with I cannot reach endpoints are network problems. We need to avoid this to go to causality from correlation, but we need to use correlation for trying to understand the problem. And that's when the reporting tools are good, because it shows you trends, it shows you different things that you can use to try to find the root cause. Second thing is you need to double check everything. I mean, maybe you are trying to verify some problem and you ask someone and he told you something, but that person doesn't have the full context of what you're doing. So it's always good to double check, and it's because then you don't go with false assumptions. The assumptions are dangerous if they are wrong, because you maybe starting a starting point that is erroneous. So all the reasoning from that point onwards is going to not solve anything. So double check everything, and then use the tools. I mean, don't try to be a superhero and go to the kernel and do a stack test with a debugger and inject some BPF, whatever thing. I mean, just start simple. This is like a detective work. If you play these Cluedo things, or you like Agatha Christie's novels and everything, or Sherlock Holmes, Deflaking test is like that. You need to generate hypotheses, use your previous knowledge, learn new things, and for that you need to have a good toolbox. So you need to be your toolbox, and that's what tools are for, or you may create new tools and share with the rest. So all of us can benefit from that. Another important thing is we saw the pyramid. Okay, when you are doing a unit test, you know that the context of the test is going to be reduced to that scope. You move to integration, you start to have etcd API server things. If you move to E2E, you start to have all Kubernetes things. And if you move to scale, you have a lot of problems that we are not going to talk here because it's complex. So you are going to need help. I mean, it's impossible, and I can guarantee you this. Nobody knows everything in Kubernetes. well, maybe Jordan but just only, but you need help because there are subcomponents. There are a lot of components that have very specific things that only the people that did that or that was around during the review know the context, and this context is fundamental. So you need to ask. But it's important when you go to ask, don't ask, I have this problem, because for the other person it's going to be busy and is not going to be able to help. So it's important to phrase it correctly. I have this problem, I done this, I checked this part, I see that you done something similar in the future, in 2 weeks ago, or this other test. So try to provide as much more information, because then you are gaining a friend, because everybody wants to solve the problem. The thing is that you don't have time, or it's complex, you need, and maybe it's not the most exciting thing, but everybody wants to solve the problem. So if you are able to engage and involve more people with you, you are going to do a lot of friends, because everybody wants to solve this problem. So I talk about Jordan. I didn't want to cover a lot of things that he presented in SIG testing. I don't remember. I think that was 1 year ago. You have this gist. He added all this documentation. He has a video that we recorded in SIG testing. It's worth to checking it. I mean, it's very educative and really must read and must watch. And most of the things that he presented, we are going to use later for the workshop. Okay. And the other thing is, a common misconception that this is, deflaking a test doesn't mean that it's like how can I say it? It's not something in itself. It's the flaking a test requires that you know what the test is doing and all the components there. So it's not that you can study the flaking test like in a career. So you need to know about, I don't know, API server, about kubelet, about C groups, about IP tables. Those all these things are required. So don't think about the flaking a test as a something that you can grow or learn. It's not a speciality. It's something that is an art, as I say. I mean, you go there, you deep dive into different things, and you try to find the problems. And it's frustrating. And I say this because I saw a lot of people that's very passionate, and they reach out and they say, I want to work on this because I want to help, and they give up because it's frustrating. I mean, and I was yesterday trying to find examples, and there are flakes that are there for, I don't know, 3-4 years, and nobody knows how to solve it, or maybe they didn't have the time. And some people you see assign to me, and then I am assigned because I cannot, and then assign to other, and just move on. I mean, this is you don't need to hit the wall continuously, because it's frustrating, and you're going to give up. And one thing is sure, we have a lot of flaky tests that can be improved. So this was a bit more an introduction. So let's go now what we have at the project. And so if you want now, I say, okay, I think that I want to deflate test, and how do I start? Okay, so one of the good things is, as I say, we have a lot of tooling that is unknown, and one of the best tools that you have is this flake test JSON report. What it gives you is the name of the job, the consistency, that means the number of times that the job ran, and divided by the number of total runs. So you can see that this is 0.932. It means that maybe I need flake it 26 times. So maybe, I don't know, I'm bad at doing this. 150 runs, and if flake it 26 or something like that. So as you can say, is not in a great shape, that job, right? And let's look what is flaking. And then you can see the test flakes, okay? And you can see, okay, the first test flake is test run, oh, sorry. Did I move from the presentation? I wanted to share, so to do it live. Okay. We work with the Kubernetes unit. Okay. So this is an example of workflow, okay? You can see, okay, this poor Kubernetes unit job is inconsistent, and this test is failing more than seven times, is failing much more than the other. So what you should do is, from here, we have this other tool that I shared before, that is, let me copy the test. Okay. This is not the page that I'm looking for, and I lost it. It's this one. Okay, we have this tool. That's a reporting tool. And you can set the job, and you can set the name of the test. And we are going to see that indeed is flaking, right? These spikes are the ones that are failing. Okay, so next thing is, let's see why it is failing. So 18 test failures today have this error message, okay? And it's saying something about a volume failing. You report to a chat attached to a node, fail, but false, expect true. Okay? Check volume plugin. So, I don't know if I have this one attached here. The thing that we need to do now is to go to the test, the reconciler test, and see what happens at that line. Okay. Do I have this test? Is this one? Okay, this is okay. So one important thing that I think is search GitHub, because if we search GitHub for the name of the test, I think that is Kubernetes, we can find an issue. So this test was already flaking and was fixed by this PR. Okay, we have the person that solved it. Okay, Paco, bad news, this test is still flaking. So, but yeah, well, we found, I'm sorry I didn't want to put you on the spot, but I'm sure that's something else. But this test is already flaky, as we can see here. Okay, but I think that this is complex to solve. If Paco didn't solve in the first try, this has to be something very complex. So we are not going to tackle this here. But I don't know. I think that this is a very basic workflow of how can you can start. You go to the report of the place, you go to the test, you start to see the different tools, and you start to deep into that. Check for the context. The historical context is important. So you know that Paco was flaking it. So the next thing that I should do is, Paco, this is failing again. Is what did you observe at the time that doesn't make sense, or why is this error? And then you start this conversation from there, and we can work. And hopefully we can fix it today, but I don't want to promise anything because. Okay. Other example that I want to see is we talked because we talked about flaky tests because of the components, but there's other actor here that influence the problem too. Is these things are running in some machine or in the cloud or in some CI somewhere, and these environmental things impact the test. And so there are some times that the test is not the problem, it's the environment, okay? And so those things are important to keep in mind because sometimes CI problems can cause the test to fail and to fail randomly. Oh, well, this is the introduction. What I wanted to do now is to do a lab, and I have a PR with different tests, so we can start going through them. And once we have these exercises done, you will know how to run your test locally and debug things. And then I have some of the tests that are in Kubernetes that I started to triage, and I think that we can fix some of them. So for the people that want to lab, you need to install these tools. And then I have a pull request that you need to check out, this one, that has 3 commits, and each commit has a flaky test. One is an unit test, other is an integration test, another is an E2E test, and you need to solve. I don't know how do you want to do it, or if you are not interested in labbing it. Or we can do groups, or I don't know, we can do it together, or I can do it, and you tell me. So what are you up to? Do you want to lab and learn how to run the test locally and these things? Yeah? You can do groups. I mean, this is not a formal talk, so be more participative.
I don't mind whichever way you want to do it. That's the thing, I'm kind of value neutral on it.
Yeah, I personally see value in people running by themselves because some of the common requests is I have an E2E test and it's failing, and I say, well, run it locally and see what is happening. I don't know how to do it, and I wanted to use this opportunity to run or the integration test. And so if you have time and your laptops and you have these tools, or at least Golang, yeah, we can start with that. You just need to check out this PR, and we go commit by commit. For this flaky test, you may get Winship in your team or Surya. For this one, 2. The problem is that I'm networking, so I only know how to do networking flaky tests. I will be, have a wider scope and give you more challenges things. I don't know, doing a tree and reverse it and see that something is broken, but not my thing. The unit test for metrics is you need some understanding on how metrics work in Kubernetes. So anybody interested in saying what's the problem here? Okay. Since you are a bit, I'm going to. Okay. So this is, sorry. So you can see, you run the test several times and fail. The other option is you run the test with the .c and it creates a binary, metrics.test, okay? And then if you use this stress tool, you can say, run this binary several times, okay? And you see it start to fail. The other option that you have in the tooling is to use the raise flag. You see, and there is a raise. The key is in the stack traces. Let me open the file. So, what is the failing? Line 39. So we need to, first thing is, don't assume anything. So just delete the deferred and see if this is really the problem that is causing the raise, okay? And you can see there is no raise. So I introduced the raise with the T parallel. So the thing is, what happens when you do T parallel? So what it does, it runs both things in parallel, right? So, okay. So if we have a raise here, what happens is something between those tests is sharing something, right? And this is why test and deflaking is not science. It's an art. You need to know. You need to know that the metrics in Kubernetes are global variables. And that's the problem, right? So those tests, so the handler was closed, but it was just the driver to the problem. You can see that this test creates some metrics and expects some other metrics, but there is other test that is that is modifying those same metrics at the same time. So this is why this test is flaky. Sometimes pass, sometimes doesn't pass. If you see, now it's passing, and I didn't do anything, but if I run it multiple times, it raises. Oh, now it's passing. Well, I think that you got the but that's the point. It's not that you know to deflect tests. You need to know that this thing changed something. There is some weird interaction between two tests, and there is some global state that is not documented anywhere. It's just that metrics are shared. And this was for the unit test. You can see that a simple thing can take a lot of time and hours until you reach out to somebody from instrumentation and tell, no, these metrics are global. Okay, don't use the parallel metrics. And the thing is, why do we have thing? Don't, okay. Oh, so they found another bug. they have a flaky test or something there. Okay, so okay. But I have the git log. Okay. We can go from here. So this one. Okay, this one is this. Somebody added a new test. Which one? Which line is starting this? Test flaking point create. Somebody added a new test, and suddenly, let me see the command to run it. One important thing with Golang is that if you don't add this count, it doesn't matter that you want to run it once. It caches the test. So that's okay. I see people, I was hit because of this and say, oh, this is working perfectly. And no, it's just the cache version. The cache version is working perfectly, but if you run it multiple times, it doesn't work. So what is the problem with integration? So we saw the unit test is, it's just one file, one function. The more that you can go is to the file that is on the other side. The problem with integration is that when you run it, you have all these nice things in your screen. Wait for it. It's 5-10 seconds. Well, and I didn't. You need to do the B thing. You have all these fancy things. So, okay, and when it fails, now it's passing. Okay, fail. But I think that you're starting to get the point. What I'm saying is there is a lot of things going on there, and this means just the API server. I don't know how many controllers they are running. Maybe 40 or more, something like that. So every single thing running there can be a problem on the test. What? And you are kidding me. So it's passing. I swear that yesterday I make it fair. I want to make it fair. Okay. Okay, it's not failing now. Okay, it's failing now. Okay, you see, I ran it several times, and this is the worst flag is, because it is weird that it fails. And we need to find the place where it failed. So one of that's the problem is, you start to need to look for the error message in the logs. That can be here. This is pass. Let me look for the fail. Okay, this is the fail. Okay, we found the fail, and then we need to start to scroll up. You could see these are shutting down. I think that, I don't know if I can make my screen bigger. And you can see this is the failure. Obtain endpoint with labels map. Obtain endpoint with labels map full bar, and got foo expected foo 2. So, and this is another gotcha of Golang. We go to the test and we say, we expect these keys, okay? And then we pause the point and try to find these keys and say, okay, we got these keys. Now, this test doesn't make sense. I'm making it up just for purpose of example. But then what I want to do is, okay, just compare the keys with the expected keys, and it fails. And you can see that they are in reverse order. Why? Because I'm obtaining this from a map, and the map keys are not ordered. So when you compare something like this, if you have any doubt, just sort it, and then you can always make it predictable. Okay. So, and the last test, this is a more complex test. This is an E2E test. So imagine that somebody added this E2E test, is flaky, and you want to reproduce it. What I personally do for all the E2E tests, I can say that I can reproduce and on my tooling, I fix everything with kind. You can use other tools, Minikube, but the main problem is that usually you need 2 or 3 nodes to run this E2E test. Okay, so if you have a cloud provider, you can spin a cloud provider, but what I do is I use kind. And let me see if I have a kind cluster. Kind create cluster already exists. Then you can compile the E2E test for the E2E test, you need to compile it, okay? That takes time, because the E2E test, the way it works is you create a binary, and the binary creates a API request to the cluster, okay? And what we need to do for the E2E test is to be encapsulated in a way that this binary shouldn't be aware that there is a communication against the cluster. So everything should be encapsulated in the environment, to the point that is, you want to test some connectivity between something. So what you do is you create a pod, that you create a server, and to check this connectivity, you create an additional pod that checks the connectivity. This way, you make your test portable and able to work in all the environments, and people can run in another environments. Now, if we want to run this test, we build the binary. So this make what test E2E, and then we just need to point it to run this binary and tell what test do we want to run. Okay, and I know what I did. I don't have a qconfig. Can get qconfig. You think, see how the complexity increases with each type of test, right? For testing E2E, you need to do much more things than for testing unit, and the tooling is different, and the way of testing it is slower, and all the kind of things. That's why I say is everybody has to create his own toolbox and use whatever they are more comfortable with. And that's the problem. The test is taking forever, and I didn't add debug. Okay. So we can cancel it on fail, and now add a verbosity label. I think that the problem is that this is going to take forever to debug. I shouldn't. For this specific, in the meantime, let me show you what is the problem in this specific test. Test it. Network. Flaking. Okay, so what does this test do? So it creates multiple host network pods, okay? And the test is very simple. It just creates a pod with host network listening port 80. And why this test is going to be fracky? The test is still running. So it's going to be fracky. I'm going to give you the solution and not wait for it to fail. Because, and this is when you need to know a lot of things. You need to know about node, you need to know about network, and need to know about scheduling and everything. When it creates a host network pod, it doesn't have network. It's a process running in the host, okay? And you see that the process is running on port 80. So if you have 5 nodes and the scheduler is scheduled each pod in a different node, it's okay. This is going to pass. You have 4 nodes. The 5th pod is going to try to be scheduled to another. I don't know. The scheduler allows this, right? David. The scheduler allows to, doesn't have any constraint on host network pods, right? Okay, so that's the thing. This process is going to bind to port 80. And there is another thing listening on port 80. So the 5th pod is going to try to be running in a place that something is already bound to the port 80. So it's going to be crash looping forever. And this is an example of a real thing that happened in the CI. You know, we have this problem. There was a daemon that was listening on port 8080 on GCE only. And it took like 1 year until we realized, oh, what is this thing listening on port 8080? And it only failed when this specific pod landed on that specific node. That is, okay, you find that by chance. Okay. I mean, these are good exercises to understand what are the problematic that we face and some lessons learned. What I had next is to go through some, okay, it's back. Is to do some real flaky detection now between all. So we go through some of the cases that is happening and we see how we can debug them. And so to make it more interactive, I'm going to go to the test and I'm going to ask questions, okay? And you guide me to see if we can find the problem. Before that, any question or anything that you want to? You already solved it. Okay, look, at least you made you made me happy because this was a useful meeting. So we solved one flake. Let's see if we can solve much more flakes. So let me check. This is not approved. I was surprised that something that you fixed it was failing. Okay, that's why you need to ask always. Okay, so no question, right? Everything is fine. So I was just doing a small triage and I have some, so you're going to see my notes and I don't want that, but this, okay, this is the one. Okay, the mount utils. Let me find it. So let's go with the mount utils. Where is the mount utils thing? So for Kubernetes unit. Okay, so right now you are at home, you are bored, and you are, I don't know, want to wind down. I used to do this on weekends, and you want to start solving flakes just for fun. So you go to this list and you find, okay, the mount utils test format thing. Next thing is, let's see the history of this guy. Next step, go to the one that gives us the history, okay? So this is the mount utils test format. Test format, we go here, job pull Kubernetes unit, test format. Indeed, it's flake, right? We can see that it's flake, and it has an, it's good, this is good because it gives you a line, okay, and a failure. Got concurrency 4 and 1.5. This, in Golang, you are going to see a lot of this problem with the concurrency because concurrency means you are going to have things in parallel running and you need to synchronize that. And that is always complex. And we have people here that is very good at that and solves a lot of flakes related to this. So we have a line, mon Linux test go 7 to 9, but then let's try to see if we can reproduce it locally, okay? So let me find this test. Let me close everything. Don't save. And I always do the brute force approach. Okay, we have the test here. And this is the one that is failing, right? Go to this format. Now we are going to run this test. Go run. Okay. Run this format. Task count 1. Why is it failing? One utils is not there. Test. Go test. Thank you. So that's the problem. Okay, it passes. Okay, let's do it with Racer. Let's compile it. Now we are going to have the binary, and let's run it with stress. But I need to specify, that's important. You need to specify the test that you want to run, or it will run all the tests in the, as you see, it's flaking immediately, okay? So, and we have a line. Let's go to this line, 7 to 9, okay? Okay, it's failing here. It's expecting something to have a maximum concurrency or something, and it's not getting it right. We can see that, and then is when you still need to start the investigation. You need to understand what the test does, okay? You can see that there is some concurrent, mass concurrent, there is a mutex here, there is something that is locking a command script, and I don't know what is failing. What can be failing here? Let me check if I have any notes about that. The flake session. No, I don't have any notes, so I don't know what is failing here. Any clue that we can check why it's failing? So this has an exec, a fake exec, a lock that is so why is this decreasing? Okay, bad example. I don't think that any of you see something that can give us any hint.
Current is greater than max current.
This one.
Yeah. Then we erase it, so it won't be the same one.
That's why I thought, right? It's a bit weird, this, right? I mean, if when max current is greater and you decrease, you are always going to be in the low spot, right? So the question is how this passes. Well,
It passes when they are equal, right? No.
no, you always decrease. No, then you must. Okay, no. So sorry. I got it wrong too. I got confused. So it's max concurrent. What changes? This is the. No, but then what is comparing here? Mass concurrent with quant concurrent. I don't know, but as you can see, it's a very convoluted logic that needs time, and you need to spend time to understand go routines, what is Excel command script, and everything. So I left this as exercise for any of you that want to learn, because it's a good challenge. I really don't have an idea. I prepared some of them here, but as you can see in my notes, I didn't get farther than say, okay, this phrase. Okay, I have another one that I have a grasp on what's the problem, and see if we can get a win and somebody can get a pull request today for getting a commit in Kubernetes. Okay, let's go to the E2Es. We have 50 minutes. I'm sorry if maybe some of you expected something different. I just wanted to get people involved in this, and I see that you can have fun, the flaking test. Okay, let's go to the list. Let's move. I have some of them that I have triage, so let's go to this one and go line by line. we have now these ones, the E2E. The top of them is this QCTL client simple. So this is for Eddie, that he fixes some of them. So we do the same. We go to the history list. Now we are changing the job. We are using this job. So we want to check the results of this test on this job. And this is the test. We click and we see, okay, it's failing. And this is the interesting thing. We go to the error and we see, fail to create FS notify watcher too many open files. What's that? I mean, we have node people here. David, what is this error, or Eddie? Yeah, but who is, another case, is this an environment problem or is something that we do? Who creates notify calls? Who adds watches or notifies? Kubernetes does, right? But in this case, is the test is triggering a watch, or is the CI that has watches and eventually hit this test? So one important thing here is you can go to occurrences, okay? And you can say, well, this is the only test failure. So the job is not totally screwed. And then you can see, okay, this is failing kubectl 8020. E2E, kubectl, 8020. Test E2E, kubectl. What is kubectl?
That's pretty below everything else.
Below?
No,
Okay. I don't know how to do it. I mean, I have it in front of me and I'm not able to see. 8.2. I don't remember never these things. I need to go 8.2.0. Okay, yeah.
Why didn't I get paged on this one?
So this is running a QCTL logs tailf run log test, right? And where is this error coming? That's the problem with E2E. And Patrick, Patrick Colley, he did he published a great blog, and he did an enormous job in E2E, and he published some of the best practices. And this is one of the best practices. What do we do with this error? Where is this error coming from? It's from QCTL, it's from the node, it's from, I don't know. That's when you write tests, you need to provide this information. 5 minutes. Okay. Yeah. It's one of the complex. So half of the problem is having good logging. If you have good logging, in this case, you will be able to say, this is a CI problem because it's running off, because this happened in the CI, right? We have some daemon that was creating a lot of files, and I don't know what was watching them, and then it ran out of notified, so you can increase there is some CTL command that increases the level. Another is that maybe we have a leak on iNotify watches, because that's happening too. So that's something that sometimes it's not to pass the test, because passing the test can be simple. You just say, well, retry it several times and see what happens. And then you have, after 2 years, we have a leak in iNotify things in Kubernetes, and nobody noticed, right? I mean, that's why I started with the thing, we shouldn't focus on pass the test. We should focus on understand the cause. And the last thing, I have one that I think that can be solved, and I wanted to show, so if somebody can send a pull request. This one. Okay. Open API. And this is the one, and I expect somebody from here to take this and fix it. So we go back to the tool, and we see Open API contains aggregated API server. Okay. We go to our search, and we say, okay, this is failing. Okay. And what's the error? And the error say, B1 alpha whatever thing example.com already exists. I mean, that's weird. Okay, let's go to the test itself. Test E2E API machinery aggregator. Test API machinery aggregator. Test 380. Okay. Okay, this is the test. Okay, and it's failing in here. Creating API, expect no error creating this object. I'm going to give you the to London read. Okay, so you go here and you see, okay, nothing happens, nothing creates these objects in the test until now. So what's the next thing to think is, well, if it fails to be created, somebody's creating this thing. So let's go to the function that is creating that, and check, okay, setup sample API server is the one that is being called, okay? And then we go test. And we can see that it's called into places. Open API v3, that is the one failing, is setting this job. This one is called by test API sample API server, and this is called by this conformance test. So what is the problem and why is this flaky? You have two tests creating the same API service in different times. So when those two tests run at the same time, they flake. So somebody can fix it, please. But I mean, sometimes you need to know, and sometimes it's weird things like this interaction. You need to know that sometimes the E2E run randomly and they come into each other and then make the test fail. So some of you please send a PR to put one of the serial or just change the name of the aggregated API server that is created to not collide. Well, that's it. I don't have anything else. If you have questions or you want, I always available in Slack for everybody that wants to contribute to make the project more healthy in the testing and solving these problems. Is always welcome.